to form cyanobenzene or benzonitrile. And this all happens simply by warming the unstable phenyl ammonium chloride with an appropriate reagent. So I'm going to show just one example here. There is a second video that looks in a little bit more detail at the reactions of benzene diazonium chloride. But I'm going to show here two examples of coupling reactions, a process known as diazotization. You see at the top the equation there, and the product there with the N double bond N, that's referred to as the diazo link. So I've got here in the syringe some of my benzene diazonium chloride solution, and I'm adding it to a phenol solution in water with some alkali to help the reaction take place. And you can see that I'm getting an azo dye produced, yellow in colour. And this later can be filtered off using a Buchner apparatus to reduce the solid, which appears somewhat browner in colour than you see here. And over here on the right I have a beta naphthol solution, again in water with a little alkali to help the reaction, the coupling reaction or diazotization reaction. And this time you see we are getting a different colour of azo dye, reddish in colour. These azo dyes are referred to as chromophores, and in another video in this series you'll see that I look at chromophores and explain the origin of the colour. So two examples of the reactions of benzene diazonium chloride. Both are examples of coupling reactions. There's the solids collected afterwards that I placed in a desiccator to dry. The dish at the top is a mixture of the other two. There's a poster created with those dyes. You can see the red of the azo compound where I coupled benzene diazonium chloride with beta naphthol, and then that more yellow colour where I coupled benzene diazonium chloride with phenol. So that's been my look at the production of benzene diazonium chloride and a look at two of its coupling reactions. Please consider looking at the other videos in this series. And thank you for listening.